Let's end by zooming out to the bigger picture of nutrition science itself. Why do we see so many conflicting studies about intermittent fasting? Why does one week's news say it's revolutionary and the next week's news says it's useless? This isn't just about intermittent fasting. This is about systemic problems in how nutrition research is conducted, published, and communicated. The replication crisis in science, where many published findings fail to replicate when other researchers try to repeat them, is particularly severe in nutrition. There are multiple reasons for this. Publication bias is massive. Positive results, studies showing that an intervention works, are much more likely to get published than null results showing no effect. Journals want exciting findings. Researchers need publications for career advancement. Studies showing nothing happened end up in file drawers. This creates a published literature that systematically overestimates effect sizes and makes interventions look more effective than they are. For every published study showing intermittent fasting produces dramatic benefits, there might be 5 unpublished studies showing minimal effects. We only see the positive ones, skewing our perception of the evidence. Study design heterogeneity makes comparisons nearly impossible. One study uses an 8-hour eating window. Another uses 6 hours. One matches calories. Another doesn't. One studies overweight people. Another studies athletes. One lasts 2 weeks. Another lasts 6 months. When you try to synthesize this literature, you're comparing apples to oranges to pineapples. No wonder conclusions are inconsistent. Long-term dietary studies are incredibly difficult and expensive. Following people for years while controlling or monitoring their diet requires enormous resources. Most studies last weeks to months, nowhere near long enough to assess sustained effects or long-term health outcomes. The findings might not persist if we actually followed people for years. Researcher allegiance effects and funding sources matter. Researchers who believe strongly in an intervention might unconsciously bias study design or interpretation toward confirming their beliefs. Industry funding can influence research questions, outcome selection, and publication decisions. While not all industry-funded research is biased, the potential for conflict exists and affects public trust. The difference between statistical significance and clinical significance is often lost in translation. A study might find statistically significant weight loss, but if it's 1 pound over 6 months, who cares? That's not clinically meaningful. But the headline will read, "Study proves intermittent fasting causes weight loss," without mentioning the effect size is trivial. Pre-registration of studies, where researchers publicly state their hypotheses and analysis plans before collecting data, helps reduce flexibility in analysis that can produce false positives. But many nutrition studies aren't pre-registered. This allows researchers to try multiple analyses until something reaches statistical significance, then present that as if it were the original plan. This inflates false positive rates. Publication of data and methods allows other researchers to verify analyses and attempt replication. Open science practices are improving, but much nutrition research still doesn't share raw data. This limits scrutiny and makes it harder to identify errors or questionable practices. Standardization of outcome measures would help. If every intermittent fasting study measured the same set of biomarkers using the same methods, meta-analyses combining multiple studies would be much more robust. Instead, every research team measures different things in different ways, making synthesis challenging. Collaborative multi-center trials, where multiple research groups work together on the same study protocol, provide more robust evidence than isolated small studies. But these are rare in nutrition due to funding and logistical challenges. For the public trying to navigate conflicting dietary advice, this is all incredibly frustrating. One study says intermittent fasting works. Another says it doesn't. Who do you believe? The answer is to look for patterns across multiple studies, ideally systematic reviews and meta-analyses that synthesize all available evidence. Don't change your behavior based on single studies, especially small preliminary ones. Look for replications by independent teams. If multiple research groups with no vested interest all find similar effects, that's more convincing than a single study. Be skeptical of dramatic claims. Extraordinary claims require extraordinary evidence. If something sounds too good to be true, it probably is. Consider the totality of evidence, not just the latest headline. Nutrition science builds slowly through accumulation of evidence. Individual studies are data points, not definitive answers. Scientific consensus, when it exists, emerges from years of research across multiple methodologies. Recognize that nutrition is complex and individual. The search for simple universal dietary rules is probably futile. What works for population averages might not work for you. What works at one life stage might not work at another. Flexibility, self-monitoring, and individualization are probably more valuable than rigid adherence to any single dietary dogma. The intermittent fasting debate exemplifies these broader issues in nutrition science. We have mechanistic plausibility, some promising short-term studies, lots of heterogeneity, and premature certainty in public communication. The honest answer to does intermittent fasting work is it depends, for some people, for some outcomes, under some conditions, and we need much more research to specify those conditions accurately. That's not satisfying, but it's truthful. And in science, truth, even uncertain truth, matters more than comforting certainty.